Hello, I'm İrem. I will start a conversation with the concept table. During the development phase of our project, we first conducted a brainstorming session to generate options for our design. As shown in the table, we listed all possible options for user interface, connection, power, and frequency. Second one is concept one. It's more detailed version of concept table. By utilizing the concept table that we created, we extracted component options that can be used for heatings. We use the AHP method to select the best options from the concept table. While using this method, we utilize the concept table and concept fund tables. And according to the result in the concept evaluation tables, we decided to use touchscreen, Bluetooth, LCD, and rechargeable battery.
Hi, I am Nisan Nuruç and I am System Engineer of the team. I will talk about strength and weakness analysis, level 0 and level 1 design. First of all, there are two methods here, and both methods have their strengths and weaknesses. We will use digital signal processing method for our projects. Level 0 design is the simplest form of our project design. Inputs are measured signal and power. These inputs are processed in signal analyzer and outputs as an LCD signal display. Here we can see more detailed form of level 0 design. Signal frequency range should be 1 Hz to 100 MHz, and our functionality determines according to customer needs. Finally, level 1 design is the improvement form of level 0 design. The signal measured with the probe and passed through the other necessary states and come to DSP. And finally, it's reflected on the LCD screen.
Hello, I'm Selin. I'm the software engineer of our team. Our table shows the basic function models of the signal analyzer we designed and the input, output, and functions of these models. We have four main models: ADC, DSP, amplifier, and filter, Bluetooth model. The flow chart shows step by step how our signal analyzer works. It clearly reveals the data collections, processing, and display step of the device. This table summarizes the general input, output, and functionality of our signal analyzer. Our class diagram represents the data flow between the environment, analyzer, smartphone, and LCD components of the signal analyzer and the properties that these components have.
Hello, I'm İrem, the team leader. We have created the use case diagram detailing how our signal analyzer processes signals until they are displayed on the LCD screen. The state machine diagram illustrates the signal analyzer behavior, the state transitions between states from signal capture to displaying on a smartphone. Our level 2 design outlines key components that probe capture signals sent to amplifier and filter circuit, processed by DSP and transferred via Bluetooth to the smartphone for analysis. The LCD screen serves as a display all powered by a battery. This test plan was prepared to test the functions of the signal analyzer device. The aim is to verify the device's time and frequency analysis as well as smartphone control. All steps were successfully completed and the device performance is functioning correctly. In the work breakdown and project plan section, you can see steps and paths we followed from the beginning to the end of the project. Although we divided tasks according to our team roles, we see the harmonious collaboration and mutual assistance within our team, ensuring that we did not work in isolation. In network diagram, we see the duration of each project phase as shown in the work breakdown structure and project plan section.
Now I will talk about work and time chart, risk analysis, and plan B. We have prepared our timeline the most efficient way to achieve success. On this slide, we have risk analysis table. First, we identified risk, then we ranked this risk according to impact, likelihood, and severity. And finally, there are plan Bs created according to risk analysis table. For example, the system can be checked for inaccurate measurement and software errors can be eliminated.
I would like to tell a little about the cost analysis of the project. The fixed cost of this project include initial investments such as equipment and software licenses required for the design and development of the device. Variable costs are expenses such as materials used in the production process, assembly, and testing procedures. And this one is personal cost. The last one is break-even analysis. It's used to determine the point at which a project's total revenues equal its total cost. Thank you for your listening.
In our project, we paid attention to designing and certifications, meeting the frameworks of these standards and legal regulations. The reliability, NTTF, NTBF, and NTTR features of our device are mentioned. Additionally, economic considerations are listed. Thank you for listening.